solving quadratics, which equations that have x squared in them, by square roots. We're going to do a quick review over simplifying square roots because we don't want to get decimal answers here. We're going to try to get exact answers with this instead of decimals. So we're going to talk about simplifying square roots first. Let's review you on that, or maybe teach you how to do that. And I do it differently than Coach Mac. So if you had Coach Mac for Algebra 1, I simplify square roots a little different way. It requires less memorization from you, but still gets the job done. You may like this method better if you're already pretty good at the way Coach Mac does it by just remembering what square number goes into that. That's fine. You can do it that way. As long as you're simplifying the square root and getting the right answer, I'm good with that out of this. So let's start with one that everybody probably knows, the square root of 49. What's the square root of 49? Why? Because 7 times 7 is 49. This is how I do these. Now, 49 is a perfect square. We usually know those, the smaller perfect squares. If I do a factor tree, y'all remember doing those in elementary school? Maybe been a while since you did one. But you just break down the number. The two things on the branches they multiply to be the number above them. And you break them down until the ends of the branches are only prime numbers. So with 49, 7 and 7 are both prime. So you stop there, and then you're looking for pairs, sets of 2, because we're taking square roots. The reason I like this method a little bit better than saying, okay, what square number goes into that one, is because when we do cubed roots, it's the same process. You just look for sets of 3. If we do the fourth root, you look for sets of 4. That sort of idea out of that. Instead of having to memorize all your cubic numbers and all your fourth power numbers and all that stuff. With memorizing squares, that's good. I'm not against that at all. I'm just saying not everybody has every square memorized past 12 times 12. It's just not common. So when this actually comes in handy is when you have a number like 24, and you think, okay, what does that deal with? Now, one method is to use the squares method and think what square number goes into 24. So I'm thinking, okay, well, it's got to be less than half of that. So square numbers are less than half of 24 would be like 9. 9 doesn't go into 24 evenly. And then the next option would be 4. And 4 does go into 24 evenly, right? So you do it that way. The way that I do it is I don't even think about that stuff. I just look at it and say, okay, 24. What's something that multiplies to be 24? 6 times 4, 12 times 2, 8 times 3. Got a lot of options and things we know that multiply to be 24. It doesn't matter which 2 you start with. If we start with 6 times 4, 6 is not prime, so we break it down. 3 and 2, right? 4, not prime, so we break it down. 2 and 2. So we have prime, 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 prime. All of them are prime, so that means we're done. Okay? Then we look for sets of 2 or pairs. So there's a pair of 2s right there. Doesn't necessarily matter that they're on the same branches. We're looking for sets of 2. There is a set of 2. 2s right there. Okay? Make my circle a little too big. What that tells me is that a 2 comes to the outside of the square root. Anything that doesn't have a pair with it goes back inside. That's 2 square root of 6. Doing it the way maybe Coach Mac does this, and I'm not sure what everybody else does as far as Algebra 1 goes. If they do the squares, you got to know the square root of 4 is 2, and then the 6 is left over. That may have been the way you learned it in Algebra 1 or the way you did it in geometry. It's the same idea, though. Where it helps me is when I get numbers like this one, 140 under a square root. The numbers start getting bigger, you got more options of things that divide into it. And I'm not really good at dividing by 36. I'm not really good at dividing by 49. But I'm pretty good at looking at 140 and knowing that that's 14 times 10. That's an easy way to get 140, right? So when I break that down into being 14 times 10, and then I've got numbers that I can deal with. 14 is 7 times 2. 10 is 2 and 5. Look at there. I've got a pair of 2's. So a 2 comes to the outside. What doesn't have a pair? 7 and 5. So they go back on the inside and multiply back together. Now, did I know that 4 went into 140? Maybe. Maybe not. Does it matter if I know that or not? Not really. We're trying to simplify a square root here. So whether you start with a square number or not, you can do this factor tree method and simplify that square root fairly easily. Let's take square root of 72. That's a good one that has tons of options as far as that goes. 72, what do we know about that number? What multiplies to be 72? 9 and 8. 9 happens to be a square number, but is 9 the biggest square number that goes into 72? I don't know. I don't think it is, but and then 8 is 4 and 2. Look at there. I have a pair of 3's and a pair of 2's. So there's 2 sets. So that means both of those numbers come to the outside. 2 times 3. And then this 2 here goes to the inside because he doesn't have a partner. Okay. Then we just multiply the outside together. That'd be 6 square root of 2. Now, what's that tell me? That tells me 36 was the biggest square number that went into 72. Most of us don't know our 36 times tables, right? That's where I'm at with this, is why I try to, most of us knew that 9 times 8 is 72. Okay, so that's the numbering is a little easier to do with this method than the squares method, in my opinion. And it also is going to help us later on. So 224. And again, if you do it the other way, I'm fine with that. It's okay. 224 is kind of a weird one. I don't know a whole lot about 224. I know it's even. So that makes it easy to start out my tree, right? 2 and then 1, 1, 2. Right? 2 goes into 224 112 times. And then 112 is also even, right? I don't know a whole lot about 112. I just know it's even, so that means 2 goes into it. 56 times. Now, 56 I do know a lot about. What's another way to multiply to be 56? 8 and 7 or 7 and 8, whichever way you want to do it, doesn't matter. 8 I know a lot about. It's 4 and 2. 4 is 2 and 2. 7 I don't have to do anything to because it's already what kind of number? It's already prime, so I don't have to do anything to it. So now I look at the ends of the branches and I look for pairs. So I've got, I got a pair of 2's right there. I've got a pair of 2's right here. This 2 and this 7 don't have a partner. It's going to be 2 times 2 on the outside. That's the 2 circled pairs. And then this 2 and this 7 on the inside. It's going to be 4 square root of 14. I didn't know that 16 went into 224, but I still could simplify the square root there. I didn't know 14 went into 224. It didn't matter as long as I break the number down. Let's do a larger one, 738. It's a bigger number. What I want you to get here is that the factor tree method can speed things up. Instead of sitting there trying numbers, you can just start and work toward the end. That's why I like this the best way. What do we know about 738? 2 goes into it because it's even, right? So we can start there. Dividing by 2 is something I'm fairly good at in my head. So 7 divided by 2 goes 3 times with 1 left over. And then 7 goes into 2 goes into 13, how many times? 6 times with 1 left over. And then 2 goes into 18 9 times. Out of that. And then 369. What? That's a weird number, but maybe I know something about some other divisibility rules that might help me. Here's one that you may not remember from elementary school. If I add the digits up, 3 plus 6 plus 9, that'd be 18. 18 is divisible by what? 3. So that means 369 is divisible by 3. That's that divisibility rule for 3. Is you can add the digits up, and if they're divisible by 3, that number is divisible by 3. That also works for 9. That 369 is also divisible by 9 because 3 plus 6 plus 9 is 18, and that's divisible by 9. So that same rule for 3 and 9. Let's use a 3. So that'd be 1, 2, 3. 123 digits add up to be 6. So I know that's divisible by 3, so I can do another 3, and that'd be 41. 41 has gotten to a smaller number. It's not tiny, but it's think about things that go into 41. Are there any things that go into 41? If it were 42, we get 7 and 6. But if it were 40, we could get 10 and 4. But it's 41. 41 happens to be prime. So not a large prime, but it's a prime number. So then we look for pairs. What's the only pair we have? 3. It's a pair of 3s here. So that's the only thing that comes to the outside. What's left on the inside? 2 times 41. And I'm writing an extra step here. I mean, I probably wouldn't, when I'm doing these, I usually don't write that step when I'm working them out. 2 times 41 would be 82. And there we have the simplified version of that square root of 738. Now, how can you verify that that's the correct one? You got that calculator that's kind of handy. If you just type in the square root, and to get the square root, you hit second and then the x squared button. And 738, we get this decimal, and then I'm going to check 3 square root of 82. 3 square root 82. I should get the same decimal. If I don't, I did something wrong. So you can always just check them in that way. That what you simplify it to be, does it match what the original was? If it doesn't, something went wrong. Okay. All right, so simplifying square roots should be something that you've done before. It may not be, hadn't done it in a while maybe, or maybe you have, and I just wasted 10 minutes of your life. But either way, you got to be able to do that to do the next thing, which is solve by square roots. Anytime we're going to solve a quadratic by square roots, we have to think differently than we do if we're going to factor. The rules for solving by square roots are you can't have a plain x and a squared piece. Okay, that doesn't work to solve by square roots. When you've got a squared piece, and that's the piece you've got to get that part isolated. Get the squared part isolated. So if we were solving by factoring, what did we have to get the equation equal to? 0 to do that. By solving by square roots, we're not trying to get it equal to 0. We're trying to get the squared part by itself before we do anything. So if we're going to get the squared part by itself, let's look at an example. Say we have x squared is equal to 49. We'll start something simple like that. What part is the squared part? X squared. This is the squared part. Is it by itself or isolated? Yes. If that's by itself, you're ready to take the square root. Okay. Now, when we take the square root of both sides, we've got to put plus or minus in front of the 49. Why? It could be either. Why can it be either?
Because two negatives make a plus.
That's exactly right. Because what's the square root of 49? 7. But also, -7 times -7 is still 49. So anytime we introduce the square root to the problem, we got to put a plus or minus in front of it. So here we're introducing the square root. And on the left side, x squared, take the square root of it, it's just x. And then this side, we're going to simplify that square root. We know the square root of 49 is 7. It's plus or minus 7. So +7 is one answer, -7 is the other. X squared minus 21 is equal to 3. So we're looking at this one, and we're trying to solve by square roots, so we want to get the squared part isolated. So what do we need to do first? Add the 21 to both sides. That's perfect. X squared is equal to 24. Squared part's isolated. We can take the square root of both sides. Plus or minus on the side with the number. And then we're going to simplify that square root of 24 the same way we did on the first 6 examples that we did. We're going to just break that down. I know that that's 8 and 3. And that's 4 and 2. There's 2 and 2. So there's a pair of 2s. That'd be x equals plus or minus 2 square root of 6. Don't give me a decimal answer. Give me that simplified square root is what we're trying to get here. Not incredibly difficult problems that we're dealing with here. Let's say we had 5x squared is equal to 80. Is the squared part by itself? Almost, not quite, right? That 5 in the front is not part of that. So we need to do what to get rid of it? Divide by 5. How many times 5 go into 80? 16 times. That's nice because now I know the next step is to do what? Take the square roots. We know the square root of 16 is 4, so it's plus or minus 4. Okay. 2 answers, +4 and -4. Okay. It's a quadratic, should have 2 answers, or at least an answer that counts twice or something like that. Say we had let's do 2x squared plus 9 is equal to 47. Make that 45, sorry. I'll make the numbers work better. Make that 45. I'll make the numbers work a little better. Just make that harder. 2x squared plus 49, or plus 9 is equal to 45. I'll be right in a second. What do we do first? Subtract 9 because it's not attached to the squared piece at all. It's not joining it. So we do that. So that's 2x squared is equal to 36. Is that right? Now what? Now it looks like example I. We need to get rid of that 2. So if we divide by 2, get x squared is equal to how much? 18. And now we've got the squared part isolated, and we need to take the square roots to solve. Plus or minus on the number side. 18, we know 6 and 3 is a good way. And then 6 is 2 and 3. So we got a pair of 3s. So a little more work at the beginning, but your goal here is get the squared part by itself and then take the square roots to solve. Where it gets a little, it looks tougher, but it's actually not that bad. When you might have something like this, x plus 4 in parentheses squared is equal to 36. So here we have a squared part. It's a little bigger than what we've been dealing with, but it's still a squared part, right? The squared part is this left side with the x plus 4 in parentheses. It's all squared. So that square part is isolated. It's by itself. So that means that I can do what to the problem? I can take the square root to get rid of the squared. Okay, that's going to cancel out the squared on the outside there and just give us x plus 4. On the right-hand side, we're taking the square root of 36, which is plus or minus what? 6. So I have two problems going on here. I've got x plus 4 is equal to positive 6, and I have x plus 4 is equal to negative 6. I can work both of those out. I just set up two problems. Because of the plus and minus, I have to do two separate problems out of that. And then that gives me, subtract 4 to get x by itself. 2, subtract 4, and get negative 10. Don't make the most common mistake I see with this every year in Algebra 1 and Algebra 2 is folks will just subtract 4 and get plus or minus 2 there, which is half right. Because we do have 2, but we don't have negative 2. So don't fall into the trap of just moving the 4 over here with the 6 and then putting the plus or minus on it. It's actually x plus 4 is equal to a positive 6, and x plus 4 is equal to a negative 6. It's two separate problems. Be very careful of that. One here, x plus 7 quantity squared minus 6 is equal to 22. So what should be our first move for this problem? Add 6, that's good. So that's going to be x plus 7 squared is equal to 28 now. Then what? Take the square root. We got the squared part isolated. It's this left side. So I'm going to take the square root to get rid of the squared. On the right-hand side with the number, I'm going to put the plus or minus. And then I'm going to break down 28. I know that's 4 times 7. And 4 is 2 and 2. So I got a pair of 2. So that's plus or minus 2 square root of 7. So I've got two different answers to work here, or two different problems to work. I've got x plus 7 is equal to positive 2 radical 7, and then I've got x plus 7 is equal to negative 2 square root of 7. How do I get x by itself? Subtract 7. Now, remember from Algebra 1 or geometry, when you're trying to put together something that's got a radical and something that doesn't have a radical, it's just like simplifying. You're looking for like terms. Because they both don't have radical 7 on them, you can't just put them together. It's going to be, you're going to write it like this: negative 7 plus 2 radical 7. It's plus because this 2 radical 7 is positive, right? So that's why we're using a plus sign there. On the other problem, do the same work, except for it's going to be negative 7 minus 2 radical 7. And those are your two different answers for that. Normally, you're going to put the regular number in front and then the radical stuff in the back. That's a standard form for that. We'll be working these. Okay. That's a little bit different, a little bit more advanced, definitely. Let's look at another one like that. Let's say we had x minus 2 squared. Let's put a 2 on the outside of that. Plus 16 equals 112. This one, a little bit more going on with it, but it's very similar to the previous one. What would be our first step? Moving the 16, the stuff that's not directly attached to the squared part. It's going to give us 2, x minus 2 squared, 112 minus 16, 96. Is the square part by itself? No. Got to get rid of this 2 in the front by division. It's going to be x minus 2 squared, half of 96. 48. Good job. Now, can I take the square root? Yeah, the square part. This stuff is by itself. That means I can take the square root to get rid of it. Square root of both sides, plus or minus on the 48 side. So I need to break down 48. So maybe somewhere I'm doing that. 48 I know is 8 times 6. You can use 12 and 4. It doesn't matter what you start with. As long as it multiplies, be the number above it. 8 is 4 and 2. We've done 8 several times today. 6 is 2 and 3. So I've got 2 pairs of 2s. So what's going to be on the outside of the square root? 2 times 2, which is 4. And then what's on the inside? 3. And on the other side, we just have x minus 2. So you can either split it up as 2 problems, and as far as on paper, I'm okay with you just doing this and writing the answer 2 plus or minus 4 radical 3. That's okay with me. If you feel better by doing this and then adding 2, so that's where you get your 2 plus 4 radical 3, and then do the other problem. Add 2. That's where you get 2 minus 4 radical 3. Either way is fine with me. I think on Khan Academy you're going to have to do them separate and write them separate. But as far as on the quiz or on paper, this is fine. Doing it that way is fine with me. I'm not. I'll take it either this way or that way. Okay. Let's do another here. Oh, let's see. Let's say we had parentheses 2x minus 1 squared plus 3 is equal to 27. That's a good one. Work out a little bit here. This was very similar to the past 2 that we've done. The only difference is the stuff inside of the squared piece it looks a little different. So there might be a little bit more to do. So what do we do first? Subtract the 3. If it's 2x minus 1 squared, and then 27 minus 3 be 24. Right? Now, is the squared part by itself? This part's the squared part. It's got some weird stuff in it, but it's still by itself. So that means I can take the square root of both sides now. So I take the square root of the left side, and that gets me 2x minus 1. And on the right side, I got the square root of 24. So I'm breaking down 24 with the factor tree. 12 and 2, 6 and 2, 3 and 2. So there's a pair of 2's and then a 6 left on the inside. Okay. So I could add 1. How do I get x by itself? Divide by 2. What gets divided by 2? Everything. Yeah, that's the right. Everything is the right answer. Everybody gets divided by 2. So if you want to write it like this, that's okay. I actually prefer doing this because which one of those will simplify a little bit? Well, I know this side does, but doesn't the same thing happen right here? You got a 2 in the front and a 2 in the bottom, so they're going to cancel out just like it did over here. It's no different mathematically. So you get x 1/2 plus or minus the square root of 6. Those are the ones that kind of can get us sometimes. We get a little confused sometimes when you got to do that sort of stuff. So there's that one. Got another one here. Let's say we had 2/3 x plus 2 plus 6 squared minus 11 is equal to 37. Okay, so what's our first step? Add 11. It's going to give us 48. This ugly looking thing over here. What next? Square root of both sides. Plus or minus on the number side. Break down 48. We've done 48 a couple of times today already. I'm going to do it a different way this time because I get bored easy. You got 1, 2 pairs of 2's with a 3. That's going to be plus or minus 4 square root of 3. It's equal to 2/3 x plus 6. So we're going to try to get x by itself. So what's the next move to get x by itself? Subtract 6. Again, it's going to just hang out there in the front. 2/3 x is equal to -6 plus or minus 4 square root of 3. What's the next step? Dividing by 2/3 is dividing by a fraction. That's the same thing as doing what? Multiplying by the 3/2, the reciprocal of that. So do that. So multiply by 3/2. What gets multiplied by 3/2? Besides this side. Everything on the other side. So it's just like the division that we did on the previous problem. We're going to basically distribute 2/3 to both of those pieces. So I'm just going to write it like this, or 3/2. And yeah, I'll just write on this 3/2. Now here's where we got to do some work. What's 3/2 times -6? 2 goes into 6 3 times. Negative 3 times 3 is negative 9. So that simplifies a little bit. On the other side, the 4 in the front you can work with. The square root of 3 you can't. So we're taking 4 times 3 over 2 is basically what we're doing there. So that would be 12 over 2, which is 6. And then the square root of 3 just stays in there. So you're just working with the number that's in front of the radical. And you've got to do something like that. Now, honestly, they don't get any more difficult than doing stuff like that. I mean, it's just the experience of being able to do that is the key out of that. It's not anything different. Now, where the lines get blurred a little bit here, because I know a lot of people, they want to say, okay, well, he said solve this one by factoring, and I have to do it that way. And if I tell you solve it by factoring, yeah, I want to see your factoring. But if I just tell you solve it, there are some that can work either way. Okay, so that's where we kind of blur all this together because it's solving quadratics. Sometimes factoring works. Sometimes solving by square roots works. Sometimes both of them will work for a problem. So an example of that would be something like this. Maybe you had 4x squared minus 10 is equal to 15. And this is one of those where I could do it either way. We're going to work this one both ways and show that it's the same problem. So if I wanted to do this by factoring, what would I need to get it equal to? 0. So if the instructions just said solve, I have that option. I have the option of factoring. Right now we have factoring or solving by square roots. That's the two methods we've talked about. We know that there are others, but so I could subtract 15 if I'm going to do factoring and get 4x squared minus 25, right? And if I'm factoring, what is that called? Difference of squares. It's something squared minus something squared. It's 2x minus 5 squared, right? And the factors for that would be 2x plus 5 and 2x minus 5. And then what do we do with each of those factors? Set each of them equal to 0. So 2x plus 5 is equal to 0. 2x minus 5 is equal to 0. And solve each of those. So subtract 5, divide by 2. Negative 5 over 2 is one answer. Do the same work over here, just opposites. Positive 5 over 2. So we get technically plus or minus 5 over 2 is the answer, right? So that's solving it by factoring. If we did the same problem, if we go up here and we're going to solve it by square roots, instead of moving the 15, I move the 10. And then what? Divide by 4. Does 4 go into 25 evenly? No. So I'm going to leave it 25 over 4. A bit of rain out there. What's the next step? Take the square root of both sides. When I take the square root of a fraction, you guys remember how to do that? You just take the square root of the top and the square root of the bottom separately. What's the square root of 25? What's the square root of 4? Is that the same two answers that I got by factoring? Yes. So solving by factoring, it works sometimes. It doesn't always. We're coming to problems where factoring doesn't always work. Solving by square roots, good option when there's only like an x squared in the problem. But either of those options can work sometimes. Not every problem works that way. But if I just tell you to solve, and I don't say use a certain method, then you have the freedom to do whichever way you think of first, or maybe whichever way you're better at. If you're really good at factoring, I would probably stick with factoring. If you're pretty good at taking the square roots, I mean, look, the number of steps is not that different. You know, it's maybe this looks a little bit longer, but as far as the work goes, it's not that much more work to do it this way. Square roots, not much less work, but it's probably maybe one step less. But it doesn't matter though. Either way, I still get positive 5/2 and negative 5/2 is the answer. So there are times where you're going to have that choice. As we get more and more of these ways of solving quadratics covered in here, you're going to have choice about which way you solve it. And some of you are really good at factoring. Factoring works sometimes. I keep saying that because it doesn't always work. Factoring is not always an option, but it's a good option when it does work because it's fast and pretty clean on solving that. Okay, so solving by square roots is what we're focused on today. There are some Khan Academy assignments that I put out there to go along with this. I will caution you on the Khan Academy. When it asks you to solve one, it will have the smaller x and then a box, and then the larger x and then a box. It matters which one's smaller. Like, so when you get an answer, make sure you know which one is the smaller one. Like, especially if it's one like 3 plus or minus the square root of 5 or something like that. Go ahead, in your calculator, get the decimal for that so you can decide which one to type in first. You're going to type it in as the 3 plus the square root of 5 and 3 minus the square root of 5, but make sure you know which one goes in the smaller box and which one goes in the larger box. Because last semester we had a lot of frustration with folks who were getting the right answers, but we're not putting them in smaller and larger, and they were really frustrated with that. So thought I'd mention that before we even got started with that today. If you haven't finished the Khan Academies from yesterday, definitely finish those. You've got some time. I know Coach Price came and got some computers, so we're a little down on number of computers today. You're going to have time tomorrow to work. So don't freak out if he said he'd be done with them shortly, and would bring them back when they're finished. So don't freak out if you don't get started on it today. If you want to work on those, you can. And that's today's lesson, okay?